Okay, so probability with tree diagrams. So what we just previously did was conditional probability, and that helps us find actual probabilities, like giving conditional events. Here's one where we're going to use probability in a tree diagram style to solve this. So we talked about event A being Canadian, right? And remember there are 100 people who are interviewed here. Remember that the English people, there were 47 of them spoke English out of this whole 100. 53 spoke Spanish as a first language out of the 100. And 50 of them were Mexican. Okay, so we had 4 different events: A, B, C, and D. So those are 4 different probabilities, and really they're set into 2 areas, right? One of them is essentially either being Mexican or Canadian, and the other one was speaking Spanish or English as a first language. So let's say we're interviewing people instead of tree diagrams. What's the probability that you get someone who just has English as a first language? So English versus Spanish. Right? When we set up a tree diagram, we go like this. English will say up and Spanish is on the way down. Well, English as a first language was a probability of 47 out of 100, and Spanish was 53 out of 100. Okay. Well, it's really easy if we just do one set. What's the probability of getting, if you randomly draw a person, that you get someone who speaks English as a first language? Well, it's 47 out of 100, right? And what's the probability that when you randomly draw someone Spanish as a first language, it's 53 out of 100? Well, that's only for one person. What's the probability that you're going to draw 4 people in a row that speak English? Okay. Well, what that means is we're going to be following the same tree. So we'll go English, Spanish, English, Spanish, English, Spanish. Now, what I want to show you is that there are many answers to this. And there are many roots. 2. So you're probably going, what the heck is he drawing? And each of these events, we'll say going up refers to drawing a person who speaks English, and going downwards refers to someone speaking Spanish. Okay, so this is the idea here. Probability that you speak English, 47 out of 100. Well, the route we want to take is we want to take 4 guys in a row who speak English. In other words, we're going to take this route through the tree diagram. Okay? Because every other route, essentially, at one point, somebody is Spanish. Okay? And we don't want to take guys who are Spanish in this specific one. We want people who only speak English. So we're kind of drawing the E's in as we go. And I'll give you an idea of what this is trying to say here. You see, there's many different routes we could take in this tree diagram. Okay. For instance, the one we want to take is drawing 4 English guys in a row. What if it asked us, well, I want you to draw a Spanish guy and then 3 English people? Well, that would be essentially going through this route. Or it would be the same as, what if they said, now that one was specific because they gave us an order to it. We want you to get 1 Spanish person first and then 3 people who speak English. Okay. What if they said we just want 3 guys who speak English out of the 4? 3 out of 4 are English. Okay. There are many different routes to this. Okay. 3 out of 4 speak English. Well, we could have got 1 English guy first and then gone Spanish, Spanish, Spanish. We could have got the Spanish guy first and then gone English, English, English. We could have got the Spanish guy first, English, English, English. We could have got English guy first, then Spanish, then English, English. We could have gone English guy, Spanish guy, English guy. Or we could have gone English, 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 last guy Spanish. So if we look here in the end, there are 1, 2, 3, 4, 5 different routes we could do for this one here. Okay, so it gets a little more complex when they're talking about
specific
in
numbers.
general. Yeah, but how do we calculate that? We haven't actually figured that out. Well, we know that English was 47, or in other words, 0.47, right? Well, that is the exact same thing every time. So it's another times 47%, times 47%, times 47%. So we take a calculator out. Okay, so it's 0.47 times 0.47 times 0.47 times 0.47 is equal to 0.048. Okay, so that's all English. That's 4 out of 4 English. And we got the probability of 0.048, which is roughly a 4.8% chance that if we were randomly drawing people from this survey, that all 4 people would be English, speaking as a first language. Okay? Now, that's because they only took 1 route there. There's another option. What about the 3 out of 4? Remember we said we had 1, 2, 3, 4, 5 different routes there? There are 5 different routes. Okay? What if they wanted to know the probability of getting just 3 people who spoke English, randomly drawing 4? Well, first of all, we have to calculate these probabilities. And this is 47, 47, 47. What's the probability of drawing a Spanish person?
60.
Yeah, 0.53. Okay? So it's a little bit different, these probabilities at the end. Okay, so we're going to take 0.47 times 0.47 times 0.47 times do it 3 times 0.47. That's 3 English guys, and then drawing a Spanish-speaking person times 0.53, 0.055. Okay. This one was 0.055, which is roughly 5.5%. But how many different options or ways could we have drawn it out? 6. Yeah, there was 1, 2, 3, 4. I think we got 5.
5.
Yeah, I think 5 different ways we could have drawn it out. In other words, we need to multiply this by the 5 different ways we could have taken those routes. Each route is a 5% chance of getting there. Okay? And we'll have to multiply that by 5 to figure out that probability. So that one's a little more complex. A little easier when they're all the same, you just multiply the same one else. So this one, because there are 5 different ways of doing it, times 5, 27.5. So in other words, if you're randomly drawing people, you have a 27% chance of drawing 3 of the people having English as a first language. And remember, that's because the order didn't matter. If the order mattered, we would have had something very different. It would have been a 5% chance. See, the one that the order mattered, remember we talked about getting someone who spoke Spanish first and then 3 English people? That order mattered. There's only one route that way in a tree diagram. And that would have gave us the same number when we multiplied. We would have done 3.47s times 1.53. Okay. And that would have gave us our 5.5%. And that's when the order mattered. But when it just said draw 3 people who speak English in general, well then I could have taken the route of taking 3 English guys first and then a Spanish guy. I could have done 2 English guys first, a Spanish guy, then an English guy. I could have gone English guy, Spanish guy, English guy, English guy. Oh, actually, this route doesn't exist. So this is a little wrong. Or I could have done a Spanish guy and then 3 English guys. Actually, it should have been times 4. There are 4 roots of that, not 5. So it's not 27. Okay? So the idea is you multiply the probabilities together when you're going through the route. So remember, to draw 4 English guys in a row, we just multiplied that probability of 0.47. We multiplied it by itself 4 times. So you could have said to the power of 4.
Oh.